Hello, my dear friends. Welcome back to Booty Aviation Training. And this is SK Booty here. And I'm going to cover today, in continuation of my last topic, heat and transfer of heat, vertical and horizontal least, and temperature lapse rate in the atmosphere. Just to remind you, those who are looking for a seat here, as I told you last time also, do well in metrology, you will do well in every subject. Okay, here we go to the next slide in this lesson, and that is continuation of the topic heat, stroke, temperature. Now, we are going to study transfer of heat, horizontal and vertical within the atmosphere. The transfer of heat takes place by two methods, sensible heat and latent heat. Sensible heat is these four methods which I explain you. And latent heat is the heat released or absorbed by a parcel of air during the change of state of vapor to liquid water to solid, or solid to liquid and vapor. The heat energy is either released or absorbed without change of temperature. Well, first is the heat traveling from the sun to the earth directly without heating the atmosphere in between. That process is called radiation. And then this heat is re-radiated. Atmosphere is heated by the heat energy which is re-radiated by the earth and not by the sun. This heat then travels through the atmosphere, through the lower levels to the upper levels. As the heat can travel through, let's say, a metal rod, if you light a candle here, this particular part will get hot and transfer the heat within the medium further on. Of course, as this heat is transferred, the heat energy keeps on becoming less. And that's what happens in atmosphere also. This process is called conduction. Then heat can also be transferred horizontally with the medium itself. That is a parcel of air moving horizontally from one place to another and carrying along with it the heat, dust energy, etc. And you get dust storms. Then, when a parcel of air is rising, it carries the heat along with it. Let's the pressure becomes low. Temperature becomes higher than the neighboring parcels of air, then this parcel of air will rise. Carry the heat along with it vertically. The heat carried upward is called convection, and the heat transferred or a parcel of air transferred downward, a parcel of air becomes cooling the neighboring parcel and sinks downward, and that is called subsidence. So convection and subsidence are vertical, advection is horizontal, and conduction is heat traveling through the medium, and radiation is traveling direct to the object without heating the medium. Now, we also studied temperature at different places will be different depending on the inclination of the rays of the sun and the specific heat. The average mean sea level temperature all over the world was calculated as plus 15 degrees Celsius, and that is known as a ISA, mean sea level temperature. And there is a average lapse rate of 1.98 degrees Celsius per 1,000 feet, which is 6.5 degrees Celsius every kilometer. The temperature will fall in a standard atmosphere. But you know, we don't have standard atmosphere everywhere. Sometimes a dry parcel of air is rising, sometimes a saturated parcel of air rising, and their lapse rate will be different. Okay. In a normal atmosphere, as your height increases, temperature will decrease. Rate may vary. This is in a standard atmosphere. And that is known as the positive lapse rate, fall of temperature with height. There are layers of air in which when you climb, but the temperature remains same, constant. That is known as isothermal layer. We'll be reading later on. For example, tropopause. Then there are layers of atmosphere in which the height increases, temperature also increases. The layer just above the ozone layer, the heat is reflected back. It goes into the upper atmosphere. The clouds also absorb and reflect back the heat. So the high level temperature may be more. During evenings when the sun is set, Earth is now releasing the heat that goes to a higher altitude inversion layer. That is called surface inversion. And there are inversion layers in the atmosphere also. And such a lapse rate is known as inverted or negative lapse rate. And the layer is known as inversion layer. Right now, we are talking about the lapse rate. Now, let's read. Is there only one lapse rate? And is it uniform? Well, certainly not. And that is why what we'll read now. First of all, the units on measurement of temperature are Kelvin, Celsius, and Fahrenheit. And this is the conversion formula. And you can also do it on your NAV calculator. Where NAV calculator is not permitted in those exams, remember this formula. We just read international standard atmosphere is the average lapse rate of the atmosphere that we have read. Now there is a DALR, dry adiabatic lapse rate. The meteorologists calculated that when a dry parcel of air rises containing theoretically zero moisture, practically there will always be some moisture present. When it is extremely low, below a certain value, they call it a dry air. When a dry parcel of air rises, it cools at the rate of 3 degrees Celsius per 1,000 feet. Okay. So, or 10 degrees per kilometer. So, in a dry parcel of air, the surface temperature is 30 degrees. At 3 kilometers, temperature will become 0, fall of 10 degrees per kilometer. In an unsaturated parcel of air, which is neither dry nor saturated, and it is rising up and cooling, we use a lapse rate of 2.5 degrees Celsius per 1,000 feet or 1 degree Celsius every 400 feet. So if your surface temperature is 30 and dew point temperature given to you in the paper is 18 degrees, and the examiner says, can you give me the estimate the cloud base? Yes. Surface temperature minus dew point temperature into a lapse rate of 400 feet per degree will give you a cloud base of approximately 4,800 feet. And cloud base is also called condensation level, where the cloud will start forming when the temperature reaches dew point temperature. After the cloud starts forming, the latent heat is released to the atmosphere. So when you go up now by next 1,000 feet, okay, 4,800 feet, now go in the next 1,000 feet, parcel will cool down due to lapse rate, but also warm up due to the latent heat received, and the net fall may be extremely small. Parcel has now become saturated. The latent heat being released will keep on becoming less and less as you go up, and the lapse rate will gradually improve. So the average lapse rate in a saturated parcel of air is called saturated adiabatic lapse rate, which is 1.5 degrees per 1,000 feet or 5 degrees Celsius per kilometer. Okay, so environmental lapse rate is the actual lapse rate in the atmosphere at any given time. If you send a radio sonde equipment which can measure temperature at various altitudes at height, it will give you the actual temperature every 1,000, 2,000 feet, whatever you have said, and you can calculate the actual lapse rate in the air. In between, there may also be isothermal or inversion layers, and that lapse rate is called environmental lapse rate. Now, just a few points to remember. When the temperatures are high, for example, in summer, lapse rate will also be high. During winter, temperatures are low, rate of fall of temperature is also low. Sorry. When you are asked to calculate ISA deviation is at any given particular level, what is the actual outside air temperature, ambient temperature, also called outside air temperature or still air temperature, minus what should have been in the ISA atmosphere. What should have been in the ISA atmosphere is calculated by plus 15. Let's say this is the here. Okay. So in the ISA, surface level or mean sea level temperature should be plus 15, and at 10,000 feet, it will be plus 15 minus a fall of 1.98 into 10,000 feet. So it will be 19.8, or we use a value of approximately 2 degrees, so it becomes 20. And so I can say at 10,000 feet, ISA temperature should be minus 5. This I have calculated for 10,000 feet. Plus 15 minus a fall of 2 degrees per 1,000 feet will give you temperature under ISA conditions. And if the actual outside air temperature is plus 5, minus, it should have been minus 5, I will say my deviation is plus 10, or the atmosphere is 10 degrees warmer than standard. I hope it is followed. And please remember, the temperature at any given altitude, the actual temperature will depend upon the environmental conditions. The surface temperature given to you by the ATC before takeoff is not the temperature of the grass or the surface where you are, but the atmosphere near the surface, and this is measured by a thermometer placed 4 feet above ground level in a screen called Stevenson screen, is also sometimes called screen temperature. So I hope in this short lesson today, you have added on to the knowledge of heat stroke temperature, and don't be surprised if you find many of these things in your examination. I'm not talking about one question, but a number of questions. Well, like I told you, keep working hard. And of course, if you like the video, then don't forget to press the like. And you like me to add some more videos for you, subscribe to the channel. And if you have some good friends, share the channel link with them. Bye bye from me, SK Booty here for today's lesson, and shall see you soon with the next lesson on meteorology. Happy landings.